Okay, we're going to continue to look at some examples to try to apply some theorems that we've learned here in calculus. The total order and transportation costs, C of x, measured in dollars. I'm just going to write that down. C is measured in dollars. Of bottles of Pepsi Cola is approximated by the function, where x is the order size in number of bottles in hundreds. So x is hundreds of bottles. Defining your variables is usually pretty helpful. So answer the following questions. Is there guaranteed a value on R on the interval from 0 to 3, such as the average rate of change would equal C prime, the instantaneous rate of change? Give a reason for your answer. This is asking for the mean value theorem. In order for the mean value theorem to apply, the graph has to be continuous on the closed interval from 0 to 3. But if you look at this function, it's undefined at 0 and it's undefined at -3, which is, both of those are fine to happen. But the 0 isn't fine to happen on this interval because it's not, that makes this not continuous on this interval. So let's write that down. C of x is undefined at x equals 0. Therefore, C of x is not continuous on 0 to 3. Therefore, the mean value theorem, the question was, is there a guaranteed value of R, such as the average rate of change equals the instantaneous rate of change? The mean value theorem does not guarantee a value of R on the interval from 0 to 3 such that the average rate of change equals the instantaneous rate of change. Just 1 second. All right, part B. Is there a value of R from 3 to 6 such that the instantaneous rate of change equals 0? So this is referring to Rolle's theorem. So first of all, is this graph continuous on 3 to 6? It is, because the only place it's discontinuous is at 0 and 3. So we could say C of x is continuous on the closed interval 3 to 6. Is it differentiable on the open interval from 3 to 6? So we could find this derivative and see if it's undefined at any particular place. If we found this derivative like this and we use the quotient rule, we'd end up with x squared on the bottom, which still points to x can't be 0. If we use the quotient rule for this, we'd end up with x plus 3 squared on the bottom, which still points to x can't be equal to -3. These are the only excluded values. Those are not on this interval. So we could say that c of x is differentiable. From 3 to 6. And then the last part, in order for Rolle's theorem to apply, c of 3 would have to equal c of 6. This is a calculator problem. If you put this into your calculator, this meaning putting a 6 into this function and a 3 into that function, you would find that this ends up being 8,333.3 repeating for each. And it's easier to figure out than you even think. Like, we don't have to know what this number is. If you put 3 into this, we end up with 1/3 plus 3 over 6, 1/3 plus a half. 1/3 plus a half. If you put a 6 into this, you end up with a 6th plus 3/9, which is a 1/3. I forget what I said the first time. Anyhow, you can use a calculator. We did. So the question was, give a reason, is there a value? Give a reason for your answer, and if such a value exists, find that value. So we could say now that, therefore, Rolle's theorem guarantees a value. So I was starting to do that by hand. I thought this will be easy to figure out, but I got to get common denominators and all that stuff. Just shove it in your calculator. It's a calculator problem. Guarantees a value of r on 3/6 such that c prime of r equals 0. Sometimes I forget when I'm doing this that I need to get these videos done quick because you don't want to watch it. So to find this value, since we can use a calculator, we would ask the calculator, like you'd put into y1 the original function, and you don't need to look at the graph. And you put into the second one n deriv of y1 evaluated at, well, into n deriv of y1, and then I believe it is with respect to x for all values of x. If you have a newer calculator, which most of you probably do, it would be the derivative with respect to x of y1 evaluated at all values of x. And then once you have that graphed, we want to know when this is going to be equal to 0. So just look where this derivative crosses the x-axis. So when you're taking an AP test, you don't have to write any of this stuff down. I'm just explaining it to you. C prime of r would equal 0. I got on my calculator when r was equal to 4.098. Part C. What is the greatest cost for order and transportation? This is the this is the extreme value theorem. The candidates that we have to choose for this, we have to choose the endpoints, And then any critical values. Well, we had a critical value that we just got up here, 4.098. Just going to make a little note here. These are the candidates. Put this into your calculator because this is a calculator problem. This is for some function C. Going to get 8,333.3 repeating. Going to get 8,213.672 and 8,611.111. What is the greatest cost for order and transportation? So we would say the greatest cost for order and transport is 8,611.111. Even though we don't round money to 3 decimal places, I think we should always round to 3 when we're in AP Calculus. And this isn't when 9 bottles are sold, it's when 900. We define up above, X was measured in hundreds. Bottles are ordered. There you go. There's our second example. It's our first example given a function in equation form.